Yo, what's up? Welcome back to another lead code problem. Today we're going to be doing permutation in string, and after this I have the general ones here. I might start doing like 2 a day, I don't know, just to move a little faster. But after that, we can move on to linked lists. Just going to be hype. But let's go ahead and do permutation in string, okay? Given two strings, S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. So if S2 contains a permutation of S1, so what's a permutation? A permutation is a rearrangement of all the characters of a string. So basically, if we had string like, S1 is equal to like AB, its permutations would be A itself and then BA. So like just every single way to rearrange that. But if we had like ABC, then it would be ABC, A, CB, um, let's see what else would be there. I guess we would do the A's first. So A, B, C, A, C, B. Okay, and then we could do like B, A, C. Could do like B, C, A, C, A, B, and then C, B, A. So yeah, here, by the way, we're looking at the permutation. Permutation here is equal to ABC. So just show you an example, right? I think I got all of them. Not too sure. Because, let's see, A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So just every way to rearrange A, B, C. Wait, now I have to know. Is this correct? Yes, it is. Okay, cool. Cool. So, yeah, this is every way to rearrange ABC, right? So you get the idea. That's a permutation. So if any of those exist, if any of S of 1's permutations exist inside of S of 2, which means a substring of S of 2, in any substring of S of 2, then we return true. Otherwise, we return false. Okay? Like, for example, if we look at this, S of 1 is equal to AB. S of 2 is EID, BAOO. But in here, we have a BA, which is indeed a permutation of AB. So I think you get the idea there. So how are we going to go about solving this? It's actually a pretty simple way to do this. Take S of 1 and run like a counter for S of 1. So basically what you want to do is you want to see how many times each element occurs in S of 1. Um, so yeah, keep that stored in a dictionary and then loop through S of 2. And then for each element at S of 2, um, subtract one frequency from S of 1 in the dictionary for that key. And while the moment the key drops below 0, we're going to start. There's going to be a sliding window, by the way. So that's going to be on the right side. But on the left side, we're going to be starting at 0. And the moment the frequency drops below 0 from the left side, we're going to start. We're going to start moving up, right? We're going to start sliding the window forward because we know that once the frequency has dropped below 0, we've used up more characters than we have available. So, and we can't do that. You can't. That means that the permutation is false. Like now, it's not a permutation anymore. So we'd have to start moving from the left. So from the left, we're gonna add to that key, whatever key's there, and then we're gonna move left forward, and we're gonna keep doing that, and keep sliding that window, and we're gonna keep checking to see. So basically, how we're gonna check, right? At the very bottom, we're gonna have an if statement, and we're gonna see if the values, the set of all values of which is basically like the frequencies of all the keys, if that's equal to set 0, like a set with just a 0 inside of it. Because if there's a set and like the only frequency is 0, that means all of the frequencies from the S of 1 hash map that we originally created have all hit 0, which means indeed that is a an actual permutation of S1. So that and we'd return true if that's the case. Otherwise, we loop through the entirety of S2, and if we never find that the permutation exists, then at the end we just return false. Okay. Now to code this out. Okay, so I guess we could have for permutations, we'll have that counter of S1, and then we'll have left is equal to 0. For right in range length of S2, what we're going to do is we're going to do the permutation of the S of 2 of whatever's at right. It's going to go down 1. Okay, so whatever's at the right side, we're going to keep decreasing that by 1 here. Okay, actually, I don't want to confuse anyone, so here's what I'm going to do first. Just to make this kind of easy. 1, 2, 3. All right, bet. First, what we're going to do is we're going to go ahead and print perm just to show you what's actually going on here. Some people might not know what this does, right? Everyone's going to know what that does. So this created a dictionary or a hash map or whatever you want to call it. In Python, it's called dictionary, so let's run the dictionary, okay? This doing counter of S1 basically takes a look at S1 and counts the frequency of every element in S of 1. So A occurs once and B occurs once, okay? This is what we have. This is what we're working with. We're working with this dictionary right here. That's what we're working with, okay? All right, so now that we know that's what we're working with, as we loop through S of 2 and look at like all the elements at the right side as we're looping through, for each of those keys, we're going to be subtracting the frequency by 1, right? So as we're subtracting the frequency by 1, what we're going to do is, okay, we're going to keep subtracting the frequency by 1. And what we're going to do is, while the moment that drops below a 0, while permutation of S2 of whatever is at right is like less than 0. Okay. The moment that's less than 0, we're going to start looking at perm of like S2 of whatever's at the left side, which is, it starts at 0. Okay. And we're going to, so it's not true anymore. So now we want to move our window forward. Let's do that. We're going to add that element back at the left. And we're going to move the window forward, or we're going to get rid of it. Sorry, we're not adding it back. This is getting rid of it basically. Because we're adding the frequency back. So it's just back to counter. It's like the original frequency for this is back there. So we don't want that anymore. And we move left forward. Minus is like it's in hold, or it's in limbo kind of, right? And then afterwards, what we want to do is, if like inside a set, if the set of perm dot like values is equal to like 0, if that's true, then we want to like return true. Okay, otherwise we'll just like return like false, right? And what's going on here is so we have the counter, right? This thing. Dot values is basically looking at all these elements here. These the values here. This is the key, this is the value. It's looking at all these values, which is the frequency of the amount of times that each character occurs, right? So basically if we get the set, right, of all of these, we had like a 1 and a 0. The set gets rid of all unique elements, so it'd just be a 1 and a 0. Or in this case, it's a 1 and a 1. It would just be a 1, right? But if both of these were 0, what would that imply, right? because we get the set, and this is what, if the both of these were 0, this is what we'd have. Like, what does that imply? That implies that we found a substring that um we found a substring that has both of these characters in a row, like in the substring right now. Like in our window, both of them exist, which means the permutation exists inside of um like uh inside of S of 2, right? S of 1's permutation exists if both of these hit 0. Which is why we're doing this check. And if that's the case, then we return true. And if none of this worked, like if we never found this, then we'll like loop through all this and we'll say we're just going to return a false. Okay, so the runtime complexity here is O of n because just like any normal sliding window, in the worst case, we're just gonna be we're always gonna be looping through like the entirety of the S of 2 string. So that is the worst case for runtime, and then the extra space is O of n as well, because we're creating a dictionary using the input S1. So in the worst case, S of 1 could be all unique elements. So there could be one key is equal to one, the key is equal to like frequency of 1 for everything in S of 1. So that could be the worst case O of n for that too. Okay. Yep. Thank you for watching, I guess.